Hello and welcome back. As we're going to work on the HPC cluster, we're going to have a short walkthrough on what this means. Of course, in such a video we can only scratch the surface, but it should give you a few ideas of what we're talking about and also pointers of where to find more information. So what is a cluster? Essentially, working in a cluster is unlike working on your laptop or your iPad or mobile phone or something where you have everything on the device or in the cloud connected to your laptop or to your iPad or whatever. A cluster is essentially a large collection and conglomerate of computers. They consist of a login node, so this is the computer you need to interact with, and then you have so-called compute nodes. This is essentially the cluster in the sense is that these compute nodes run the programs that you want to execute. Then you have some sort of storage areas. Typically you have a home area. This is where your programs live, your code lives, your configuration files, your results are, and you'll have some sort of storage area. And you can't run jobs directly because there are so many users, potentially thousands of users that want to use the cluster at the same time. You sort of have to use a scheduler, a software that you tell it, please run this program for me. And this is what we typically call a batch system. So the high-level overview is that you log into the login node and copy all the relevant code and configuration files in there, and then you write a script that you then pass on to this batch system, and that schedules the execution of your code for you and notifies you when your job has been computed. So it's also not that you run this job, you submit it to this batch system, as we say, and then instantly it runs. And then you can just wait until it's done. Typically you may wait for a couple of hours, maybe sometimes also even days or longer for your job to start. That depends on the overall usage of your cluster, both for yourself but also from all the others, and the number of resources that you require. So let's go through this step by step. The login node is sort of a gateway that gives you access to the cluster. This is where you can work with your home directory and you can send jobs to the cluster and retrieve the output from to work, for example, on your personal desktop, your iPad, on your laptop to make a nice plot for your scientific publication or something. And then you interact with this cluster, and almost all clusters run on some Linux variant. So that means you will also know some basic Linux user commands, and also for most things there isn't a graphical user interface. You actually have to get used to needing to use a terminal on the command line and type in the relevant commands. You also have a file system where you can store files, and here on the right there is the general structure of a Linux file system. It's a bit unlike what you have on your iPad, where you have apps that sort of store your documents or images or whatever in some area, but you actually don't know really. You just open the app and you have access to those. Here you need to know where to put things. So everything is stored in directories on these file systems. That goes for program code, data configuration, and so on. And typically you have a lot of system directories, so they are there for the general system programs or the general system configuration and so on. This is where you don't need to interact with, but you have your home area /home and then /user, or the environment variable $home always points to your area, and because this is a multi-user system, it's not just you but thousands of people who work on this system at the same time. And all of these directories don't have to reside on a physical computer together. Typically they aren't. Especially you have the login node, and this login node has some sort of system directories to run the operating system, but it then, as we call it, mount or loads the directories for your home directory and storage directories from other servers, from dedicated storage and home servers. Generally, the home area is typically back up, and the areas where you put your data is typically not back up, but it's much larger. So in each system you have a home directory that you can access either via the environment variable $home, or the full path is /home/user ID, and here in HPC Aachen, your user ID is related to your TIM ID. So the home directory is where you put your configurations, your source code, your programs, and so on. And here in the HPC cluster in Aachen, you have 250 gigabytes of storage for this, and it's backup. So it's not meant to store a large amount of data or output, but it's really meant for program files, configuration, and the things you want to interact with. And then you have the data directories, and HPC Aachen, there's a link to the general overview, but essentially it boils down to you have $work, and this is on a different server. You also have 200 gigabytes there, no backup, and you have HPC work with 1 terabyte per user. It's meant for large files, also no backup, so you need to make sure that the data you either provide to your programs or you compute or retrieve from the computation of running your program is sort of stored in a safe location. We've already mentioned the batch system because the cluster is meant for many users and all resources are shared. So you can't run a job when you like it. It needs to be scheduled, and this scheduling depends on your quota. That means how many jobs have you submitted so far, but also what kind of compute capability, shall we say, have you either paid for or applied for, right? So if you have very compute intensive jobs, you can apply for a grant, like for example a thesis grant or a research grant here at the university, and then depending on how big this proposal is, it will need to be peer reviewed. For smaller proposals, that's not necessarily the case. So if you have then access via such a grant to a larger quota, you can run more and longer jobs. But everyone has some sort of quota that you can get started. It also, the scheduling depends on how long does your job need to run. Of course, it makes a difference if your job runs for like 5 minutes or 24 hours, right? If you request a job to be able to run for 24 hours, the scheduling system needs to find a slot where it can find 24 hours of consecutive time. If you only request 10 minutes, this is much easier, of course. And it depends on what kind of resources you require. The cluster is big, but not infinite, right? In particular, it only has a finite amount of graphics card. So if you require a graphics card, you may have to wait longer because other people also want a graphics card. At HPC, at HPC Aachen, we use the Slurm system to send jobs to the compute nodes and then get the output from the computations back. So Slurm is a job management system that manages, as the name says, which job runs when. So how you do this, you log into the login node, set up your program with the appropriate script so they could run and they have access to all the information, input data, configuration files, and so on, right? And then here's a link to the Slurm documentation. You can submit it with sbatch, and then the batch script is the code that will then run on the compute node to execute your program. You can view your queue, or if you need to cancel your job. You also need to choose what's called a suitable partition, and that depends on what you need. How much memory does your compute node need to have? If you require a GPU and so on. It essentially tells the Slurm system which part of the cluster, shall we say, to submit your code to. So here's a minimal job script that you can have. So we have a dedicated shell that runs on the cluster. You also need to use this one. And then there are a few job parameters, right? So this is what you need to specify in the beginning. So here, for example, we say we want to run for 15 minutes and give it a job name, but you don't have to. And then you put in the output node, the standard out. This is essentially what would be written on the screen if you ran interactively. That node needs to go to some text file, and we call it a standard out. And you can also give it a project ID or just delete the line if you don't need to. And then down there where it says as run hostname is a program from Linux, so it just gives us the name of the compute node, but the syntax is as run, and then your program goes here. As we said before, clusters typically run on Linux, so here are a few basic Linux commands that you need to know, but please also take the opportunity to practice a bit and find further resources to get more familiar with this, but this is essentially what you need to get started. So ls means list the contents of the current directory if you don't give anything, but you can also give it ls and then a directory name, then it lists the directory of a specific directory. The two dots always mean the parent directory, or like one level up. So ls ... means list the contents of the directory one level up, or you can specify the full path, and we always use forward slashes on Linux. So you can specify this directly with ls path to some other directory somewhere else. Of course, you can change directories, so you can use cd change directory and you give it the directory name, or if you do cd and then nothing, you go back to your home directory. You can also then specify the full path, of course. You can create new directories with makedir, mkdir, or remove files or remove directories. So if they're empty, but you can also force remove files or directory, or do this with the R parameter recursively, but beware, right? Force means it will not ask you again, it's then gone and gone forever. There is no trash can or bin or whatever it's called on your operating system that you use. Normally, if you type in r-f or r-rf and you give it the wrong file or directory, this is gone forever. You can also copy it with cp copy or mfar for move, or if you then, because you need to get your data from and to the login node, you can use secure copy. Sometimes you need to put stuff together, like in a zip archive, as you, for example, use on Windows or Macs as well. So there's a Linux equivalent. You can zip or unzip, or g-unzip for the GNU and open source variants. You can use these, or the Unix archives are typically called tar archives, and there's a command tar, and you can unpack a tar archive with the following command. If you want to have more information about a command, you can write man for manual, man and then the command name. That opens the manual on the screen. So for example, man is a Linux program, you can write man, and that would open the detailed description about the program man, giving the manual. There are of course many more commands that you will eventually need, but these should get you started. It's probably a good idea to look at the tutorial. There's one for Ubuntu, but there's also the LTR Getting Started guide. One key thing to work on the cluster: if you have your own personal PC or your laptop or your iPad that is dedicated to you, so you install the programs in a specific version, and also the libraries and drivers and everything that needs to be installed to run a certain program, and you also choose the program that you want to have. The cluster is shared between thousands of users, and each user of course have different programs, and typically it happens that different versions of different programs are not compatible with each other's, or that you can't have two programs installed at the same time and so on. So one solution to this conundrum is to put everything into so-called modules. So the compute nodes and also the login nodes are sort of bare bone to start with, and if you then need specific part, for example a given Python version or GPU drivers for deep learning and so on, these are put into modules, right? And this module system allows then different users to load modules in different versions depending on their requirement at the same time in their environment. There's more documentation about the module system there. It's based on lmod, and the minimal list that you need to know is module load and then the module name and version that you have. You can also unload it if you load the wrong one, or if you want to change your environment. Right? First you had version 1 and now you need version 2, so you need to unload version 1 and load version 2 and so on. You can list all the modules that are there. You can do module purge and then remove everything that you've done so far. The command module spider gives you more information. You can also of course have a list of all the modules that are currently available.